Okay, so this is a chapter 21 question. It has to do with electric forces of three charges on a distance from each. The question asks you to find the resulting force on charge C. So in order to do that, we have to first find the force of each, find the components, find the net force between those components, and so on and so forth. Okay, so let's start. So the first thing is knowing the effects of these charges on charge C. You can't see it right here, but charge C has a +5 microcoulombs is what the charge is. So they tell us that the distance from here to here is 25 centimeters, which is 0.25 meters. And they tell us the distance from here to here is 15 centimeters, which is 0.15 meters. And so using Pythagorean theorem to find C, we get that C is a distance of 0.29 meters. Okay, great. So now what? Well, I came here on this side. Let me go back here. So what I did here was I pinpoint my point C. This is my point C. And I saw the effects of each, and it's color coded for easy on the eyes. So red is the effect of A on charge C. This causes a repulsive force. This is a positive charge. This is a positive charge. A repulsive force directly straight this way, right? Like that. And so B is a negative charge. This is a positive charge. So it's going to be an attractive force this way. And that force is obviously going to be something like that. Okay. So this is what I have here, this force towards this charge here, and this repulsive force from this charge over here. So now I found the Y and X components of each of the force, right? So the first thing that I did actually was I found the force A on C, just blatant force. And I used obviously this equation, which I used for this one as well. And I got a force of 2.13, right? And then I got a force of 3.21 for my force of B on C. So the force here, this is 2.13 newtons, and this is 3.21 newtons. Great. So then we find our X components for the, I'm so sorry. So then we find our X component for the force of B on C, and that's going to be 3.21 sine of 30. Why 30? Great. So this force, as you can see here, has an angle with this axis that I've made it, right? I made this axis. And so I'm looking at the angle from here, right? Because I'm looking at this angle from here as well to get that X and that Y. So what I did was, this is the sine. My f of X of B and C is 3.1 times sine of 30. I got this angle by using tangent or the arctan to find theta, and that gave me 65 degrees. That gave me 60 degrees. I'm sorry, I wrote this incorrectly when I did the math. This gave me 60 degrees. And so then this has to be 30 degrees. Then for the Fy of B on C, same thing, except now we're talking about cosine, and that gave me 2.78 newtons. But the same thing for X and Y, it's the same sine of 30. And I got that for that, and then for the same thing but cosine, I got 1.84 newtons. So now I have to find my F net. Well, my net force on the X, right? So my net force along the X is going to be 1.65. This force here minus this force here, right? And that gives me 0.54 newtons. And then my F net Y is 0.94 newtons, which is this force Oh, wait, this is additive force. This you add. I apologize. I'll fix it now. This you add. So let me add it. 2.78 plus 1.84 is 4.62 newtons. So why am I adding it? Well, because they both have a y component, and it's both in the downward direction. So like you can see here, right here, you see how they both have in the y. So this is just gonna add. These we subtracted because they went in opposite directions. So you add those and you get 4.64, and then you're supposed to find the resultant force of that. So what we have is C feeling a force, a Y force of 4.62 and a force along the X of 0.54. So what we want is this resultant force right here. And to get that, we use Pythagorean theorem, which is that. So that would be 0.54 squared. That's fine. It would be here that we change it because I made that mistake. And it's 4.62 squared. And then when I do the math, I should get 4.62 squared plus 0.54 squared. I get a force of 4.65 newtons. That's my resulting force. Hope I did that right.